Good morning to all of you. Today we will discuss engineering thermodynamics, which is a part of basic mechanical engineering. This is BPD first semester and second semester course. This is for BPD first and second sem. Clear? This question number 35. Already I have done 34 number of questions. The question is the heat capacity at a constant pressure is given by Cp is equal to 2.093 plus 41.87 by T plus 100 joule per degree centigrade. Clear? The system is heated while it is maintained a constant pressure of 1 atmosphere. Pressure remaining constant. While the volume changes from 2000 cm3 to 2400 cm3 and the temperature increases from 0 to 100 degree centigrade. Clear? Find the heat transfer and the change in internal energy of the system. Clear? Very important question. This is given by Cp. Cp is a function of temperature. Clear? The temperature starts from 0 and up to 100 degree centigrade. Temperature changes from 0 to 100 degree centigrade. So first we'll find out the Cp at 0 degree centigrade and Cp at 100 degree centigrade. Then I will take a average value. Right? Now, given T1 is equal to 100 degree centigrade, T2 is equal to T1 is equal to 0 degree centigrade, T2 is equal to 100 degree centigrade. Clear? What is this? 273 Kelvin. What is this? 100 plus 273. 373 Kelvin. T2, T1. The volume changes from 2000 cm3 to 2440 cm3. Volume. V1 is equal to 2000 cm3. Clear? 1 cm is equal to 1 cm is equal to 1 meter is equal to 100 cm. Right? So 1 cm is equal to 1 by 100, 10 to the minus 2 meter. 1 cm square is equal to 10 to the minus 4 meter square. 1 cm cube is equal to 10 to the minus 6 meter cube. Right? So convert cm cube into meter cube. So what is V1 is equal to 2000 cm cube. That is 2000 into 10 to the minus 6 meter cube. V2 is equal to 2400 cm cube. Clear? This is 2400 into 10 to the minus 6 meter cube. This is V1, V2. Pressure. P is equal to 1 atmosphere pressure. What is 1 atmosphere pressure? I have already given you 1 atm is equal to 101.325 kilopascal. Right? This is 1 atmosphere pressure. P. Temperature changes from 0 to 100. Volume V1 is V2. This is pressure P. First find out the value of Cp. This is joule per degree centigrade. Clear? This is joule per degree centigrade. Here the temperature is in centigrade. First find out Cp at 0 degree centigrade and Cp at 100 degree centigrade. So at 0 degree centigrade What is Cp is equal to 2.093 plus 41.87 by 0 plus 273. Clear? This may be 2.5112 joule per degree centigrade. This is 2.5112 degree per centigrade, joule per centigrade. Similarly, at 100 degree centigrade, what is Cp is equal to 2.093 plus 41.87 by 100 plus 273. This is 2.4 2.293 per degree centigrade. This is also joule per degree centigrade. Clear? This is Cp, this is Cp. This value is at 0 degree centigrade, this value is 100 degree centigrade. So take an average value. So take Cp is equal to 2.4. Clear? Joule per degree centigrade. I have taken an average value. This is value of Cp, this is value of Cp. This is 0 degree centigrade, this is 100 degree centigrade. So take an average value. Cp is 2.4 joule per degree centigrade. Clear? Then what done? Mass. What is the mass? Mass is 1 kg. Given mass is equal to 1 kg. Clear? All values are given. All data are given. B1, B2, P1, P2 all are given. First find out what done. Number 1. What done? W is equal to P into B2 minus B1. What is P? P 101.325 kilopascal, kilonewton per meter square. B2 minus B1 2400 minus 200 whole into 10 to minus 6 meter cube. This meter square cancels. Clear? We will find out what is kilonewton meter. Answer is kilonewton meter. Kilojoule. Clear? Kilonewton meter, kilojoule. What is what done is equal to? This is 10 to minus 6. So 3 cancels out. This may be 101.325. Clear? 2.4 minus 2 into 10 to 3 10 to minus 6 kilojoule. This is answer. Right? This is answer. This answer may be, this cancels out 3. So what is what done is equal to? This answer is 40.2 into 10 to the minus 3 joule. 2.4 minus 2, 0.4 into 101. Clear? May 40.2 10 to the minus 3. This is minus 3 kilojoule. Clear? This is what done. So what is this? 40.2 joule. This is what done. Kilojoule. 101.325 into 0.4. This may be 40.2 into 10 minus 3 kilojoule, that means 40.2 joule. This is what transfer. Heat interaction or heat transfer. Number 2, heat transfer. Q is equal to, for constant pressure process, the process is constant pressure. What is constant pressure? Isobaric. This is isobaric. Right? T2 minus T1. What gem? 1 kg. Clear? What is Cp? 2.4 joule per degree centigrade. T2 minus T1 degree centigrade. So this 100 minus 0, this centigrade. Cancels. So joule, answer is joule. Or since it is 1 kg, so answer is joule. What is Q is equal to? 240 joule. Clear? Just write this joule per kg degree centigrade. Clear? This is joule per kg degree centigrade. So kg gets cancelled, the answer is joule. Heat transfer or done. Now change in internal energy. Now change in internal energy. Del U. Clear? Del U. What del U? According to law of conservation of energy, what is Q is equal to? Double per del U. Right? 2 plus del U. So what is del U is equal to? Q minus W. Q 240 minus W 40.2. This is joule, answer both is joule. So del U is equal to 199.8 joule. This answer. This answer 35. Now I will do 36. This is question number 36. Very important question for board examination. Right? The question is, an imaginary engine receives heat and does work in a slowly moving piston such that the cycle of operation for 1 kg of working fluid is represented in a circle on a PV diagram, in which one semi is 300 kilopascal and one semi is 0.1 meter cube per kg. This is pressure, this is volume. How much work will be done by each kg of the working fluid? That is, mass is 1 kg. If the heat rejected by the engine in a cycle is 1000 kilojoule per kg, find the thermal efficiency of the engine. right? First, I'll find out the work done. In a PV diagram, the area of the PV diagram is equal to work done. The area represents the work done in the cycle. Suppose this is volume, this is equal to pressure P. This circle, the diameter is 10 cm. What diameter? Tension. Clear? Diameter is 10 cm. The imaginary circle represents the work done in the PV diagram. The area of the circle, its diameter is 10 cm. This is pressure P. This is volume V. In volume, 1 cm is equal to 1 cm is equal to kilopascal. In volume, 1 cm is equal to 0.1 meter cube per kg. Clear? Now, first I'll find out the work done. First, given mass, given data, body mass is equal to 1 kg. What diameter circle is equal to 10 cm. So, what is the area of the PV diagram? Area under PV diagram. A is equal to what is the area? Pi A4 d square. Right? So, pi A4 into what is d? 10 square. So, pi A4 into 100. Answer is cm square. Clear? This may be 78.539 cm square. This area of the circle. But this area represents the work done. The area under this PV diagram is equal to the work done. But the area is cm square. But work done is joule or kilojoule, not cm square. So convert the cm square into kilojoule or joule. Right? Now, in PV diagram, one cm is equal to 300 kilopascal. That means 300 kilonewton per meter square. Clear? Again, one cm on volume diagram, on volume line, 0.1 meter cube per kg. Clear? So this is pressure line, this is volume line. So what is area? What is 1 cm square? Now, 1 cm square is equal to 300 kilonewton per meter square into 0.1 meter per kg. This meter square cancel out. 41 cm square is equal to 30 kilonewton meter per kg. So 30 kilojoule per kg. Right? The 1 cm square. But what is the area of the PV diagram? 78.539 cm square. area of PV diagram. What is area of PV diagram? A is equal to what done? What is this? 78.539 cm square. Right? This is equal to what done is equal to 78.539 cm square. What is 1 cm square is equal to 30 kilojoule per kg into 30 kilojoule per kg. Clear? This answer what done? What is this answer? This may be 2356.7 kilojoule per kg. So what is what done is equal to 2356.7 kilojoule per kg or 1 kg. This answer for what done? Since m is 1 kg, since mass m is 1 kg, what is what done is equal to 2356.7 kilojoule per kg into 1 kg. Right? So what is what done is equal to 2356.7 kilojoule. This answer for what done? Right? Given the heat rejected is 1000 kilojoule. Given heat rejected QR is equal to, what is QR is equal to 1000 kilojoule per kg. 1000 kilojoule per kg for 1 kg. Since for m kg, for m is 1 kg, but heat rejected QR is equal to 1000 kilojoule per kg into 1 kg. Right? So QR is equal to 1000 kilojoule. The heat rejected QR, what done W? First find out what is the heat supplied. Heat supplied US. What is what done is equal to heat supplied minus heat rejected. QS minus QR. So what is the QS is equal to what done plus heat rejected. So what is heat supplied is equal to what done 2356.7 kilojoule plus 1000 kilojoule. So heat supplied QS is equal to 3356.7 kilojoule. Clear? This is heat supplied. Now, thermal efficiency. Thermal efficiency. Eta thermal is equal to what done by heat supplied. What you have done? 2356.7 kilojoule by it's applied 3356.7 kilojoule. Clear? This is efficiency. This may be 0.702. This is called 70.2%. Ita thermal is good. Clear? This answer. This is the answer. The efficiency is 7.2% and QS is this. What is equal to 2356.7 kilojoule per kg. Clear? Next question. 37. Question number 37. This is question number 37. Very important question for repeat examination. This is a long question, 60 marks question. The question is, a gas undergoes a thermal cycle consisting of three processes. Beginning at initial state, this is P1. P1 is 1 bar, V1 1.5 meter cube, U1 512 kilojoule. The processes are as follows. Process 1 to compression with the PBL constant. 2 P to 2 bar, U to 690 kilojoule. Process 2-3, double 230, and Q23 minus 150 kilojoule. Process 3-1, double 3-1 50 kilojoule. Clear? Find neglecting K and P. Kind energy neglected, potential energy neglected. Find the heat interactions Q12 and Q31. For during process 1-2, find heat transfer. Process 3-1, find heat transfer. Right? Now start from process 1, state 1. Process 1-2. Process 1-2. Clear? This is very important question. For process 1-2, first write the given data. P1 1 bar. What is P1? 1 bar. Means 100 kilopascal. 100 kilopascal. What V1 is equal to 1.5 meter cube. What U1 is equal to 512 kilojoule. Right, first write given data. Then process 2-3, 1 to PV constant, P2 is equal to 2 bar. Means 200 kilopascal. Clear? And U2 690 kilojoule. What U2? 690 kilojoule. Clear? This is process 1-2. So for process 1-2, this is PV constant means isothermal process. The process is P visual constant. That means this is isothermal process. So what is what done for isothermal process? So what done? What done? P1 V1 ln V2 by V1, or V2 not given, only V1 given. The process is PV constant. So P1 V1 is equal to P2 V2. So what is there? P1 by P2 is equal to P2 by V1. Put this V2 by V1 here. Clear? Now what is this? P1 V1 ln P1 by P2. Clear? This is what done is equal to P1 100. This is kilonewton per meter square. V1 1.5 meter cube. Ln P1 by P2 100 by 200. Clear? This is what done. This may be minus 103.9 kilojoule. Minus 103.9 kilojoule. What done? Change in internal energy. Change in internal energy. Del U12. Clear? U2 minus U1. What U2? 690 kilojoule. 690 kilojoule minus 512 kilojoule. Both are kilojoule. So what delta U12 is equal to 690 minus 512. This may be 78 kilojoule. Clear? This is what done? This is heat transfer. So the question is U2 is equal to this 178 kilojoule. Clear? U2 means U1 690 means 512 178 kilojoule. So what is heat transfer? Now heat transferred Q12 is equal to W12 plus del U12. So Q12 is equal to what? W12 130 point minus 103.9 kilojoule plus U12 178. Clear? This is Q12. This Q12 may be 74.9 kilojoule. This is process 1 to answer Q12. Now process 2-3. Process 2-3. So during process 2-3, what heat transfer? Process 2-3 given 2230 is equal to 0 and Q23 is equal to minus 150 kilojoule. Right? Now what is Q23 is equal to? This is Q12 is equal to 74.9 kilojoule. This is answer. Clear? Now, process 2-3. What is Q23 is equal to? Double 2-3 plus del U 2-3. Right? So Q23 means minus 150 is equal to double 0 plus del U 2-3. Del U 2-3 you will find out. U3 minus U2. So minus 150 is equal to U3 minus what U2? 690. What U2? U2 maybe 690. 690. So what is U3? Minus 150 plus 690. This is equal to 0, 4, 5. 540 kilojoule. Clear? So U3 is equal to 540 kilojoule. This is process 2-3. Then process 3-1. Process 3-1. What is Q31 is equal to? Double 3-1 plus del 2-3-1. Double 3-1 50 kilojoule. Clear? So what is Q31 is equal to? Double 3-1 50 plus U1 minus U3. Right? So Q31 is equal to 50 plus what is U1? U1 512. 512 minus U2 540, U3 540. So minus plus 50 plus 512. This is 562 minus 540 is equal to 22 kilojoule. Q31. Right? This Q12, Q31 is equal to 22 kilojoule. This is your answer for this question. Now, I will do another question 38. This is question number 38. The question is a system composed of 2 kg of fluid. What is mass? 2 kg. Expands in a frictionless piston cylinder arrangement or piston cylinder machine. From initial condition 1 megapascal 100 kilopascal to the final state of 30 degrees centigrade. 1 megapascal 100 degrees centigrade to 30 degrees centigrade. If there is no heat transfer, find the work done for the process. Take Cb is equal to 0.718 kilojoule per kg Kelvin. Right? First write the given data. First write given data. Mass. What is mass of fluid? 2 kg. M is equal to 2 kg of the fluid. Expands in a piston cylinder machine arrangement from 1 megapascal, P1, 1 megapascal. Clear? 1 megapascal, how much pascal? Is equal to 1 into 26 pascal. Clear? 1 into 26 by 23 kilopascal. Clear? So P1 is equal to 1000 kilopascal. This is P1. Now T1 100 degree centigrade, T1, T2 30 degree centigrade, T1 is equal to 100 degree centigrade. Convert centigrade into Kelvin. 1 degree centigrade is equal to 0 degree centigrade. You will convert centigrade into Kelvin by summation of 273. Clear? So this is equal to 100 plus 273 is equal to 373 degree Kelvin. Clear? Similarly, T2 30 degree centigrade. 30 plus 273 is equal to 303 Kelvin. Clear? 1 Kelvin is equal to degree centigrade plus 273. Right? So 100 degree centigrade, 100 plus 273, 373 Kelvin. T2 30 degree centigrade. So 30 plus 273, 303 Kelvin. Clear? No heat transfer, Cb. What Cb is equal to 0.718 kilojoule per kg Kelvin. This is Cb. No heat transfer. No heat transfer. But Q is equal to 0. Clear? Find the work done for the process. Find the work done for the process. Clear? This is question. So first find out what is change in internal energy. Now change in internal energy. Del U. Del is equal to M CB T1 is T1. Clear? What is M? 2 kg. CB or CB 0.718 kilojoule per kg Kelvin. Clear? Into T2 is T1. T2 means 373 minus 303 Kelvin. Kelvin cancel out, kg cancel out. This answer is kilojoule. Clear? So what is Cb is equal to? What is delta U is equal to? Delta is equal to 2 into 0.718 into 70 kilojoule. Clear? This is del U. But del U is equal to 100.52 kilojoule. T2 minus T1. This is 303 minus 303 minus 370. This is minus. So minus 100.52 kilojoule. This is del U. Energy decreases because the temperature decreases. Now, what transfer W? What transfer W? What is Q is equal to W per del U. So Q 0 is equal to W plus minus 100.52. This is kilojoule. So W is equal to 100.5 kilojoule. This answer. Clear? This implies 0 is equal to W plus minus 1.5 kilojoule. Clear? This is equal to, bring this side. So W is equal to 100.52 kilojoule. This answer. Clear? Next class, I will do some theory, right? Then I will start some problems. Thank you. Please make like, share, subscribe for each channel. Thank you.